The color-changing milk experiment, often referred to as the magic milk experiment, is a captivating demonstration of basic chemical principles that can be easily replicated at home or in our school. This experiment involves adding drops of food coloring to a shallow dish of milk and then introducing a drop of dish soap, which triggers a mesmerizing display of swirling colors. To further understand this experimentation, here's a breakdown of science behind this phenomenon by addressing these following questions. For number 1 question, how does the color-changing milk experiment work? So based on our observation, color-changing milk experiment work because of the surface tension, fat molecules, and the detergent. So the first one is the surface tension. Milk, like water, exhibits surface tension, a property that makes its surface act like a thin or elastic film. This tension arises from the cohesive forces between water molecules, causing them to cling together at the surface. The second one is the fat molecules. Milk contains fat molecules that are suspended in water. These fat molecules are hydrophobic, meaning they repel water and tend to cluster together. And lastly, the detergent soap. Dish soap is a surfactant, a substance that reduces surface tension. When detergent is added to milk, it disrupts the cohesive forces between water molecules and weakening the surface tension. When a drop of dish soap is introduced to the milk, it immediately starts to break down the surface tension. This disruption causes the fat molecules to move away from the soap, creating a swirling motion that carries the food coloring along with it, resulting in the vibrant, colorful patterns we observe.
Question number 2. The science behind the milk and food coloring experiment. The color-changing milk experiment is a visual representation of several scientific concepts. The first one is the initial stability of the food coloring drops on the milk surface is due to surface tension. Next is emulsification. The soap acts as an emulsifier, breaking down the fat molecules in the milk and dispersing them throughout the water. This process is similar to how soap cleanses grease and oil from dishes. And lastly, the molecular movement. The swirling motion observed is a result of the rapid movement of fat molecules as they react with the soap. This movement carries the food coloring along, creating the mesmerizing patterns.
This is my explanation in the color-changing milk chemical reaction. The color-changing milk experiment involved the interaction between different substances. It's not technically a chemical reaction. A chemical reaction involved the formation of new substances with different chemical properties. In this experiment, the milk, food coloring, and the soap remaining chemically unchanged. The swirling pattern are the result of physical changes, such as a description of the surface, tension, and movement of the fat molecules.
Good day! I am Angkup Amraida, Group 1 from Orem. The question is, why does food coloring not mix with milk? So this is my good answer. Food coloring, being water-based, doesn't really mix with milk because milk is a complex mixture of water, fat, and proteins. The fat molecules in milk create a barrier that prevents the food coloring from dispersing evenly. Thank you.
Is it safe to drink food coloring? Food coloring is generally considered safe for consumption in small amount, as it's regulated by food safety agencies. However, there are concerns about potential health effects from excessive consumption. Particularly in children, some studies suggest possible links between artificial food coloring and hyperactivity, though more research is needed to confirm this. It's important to note that the color changes milk experiment is intended for educational purpose and should not be consumed.
For question number 6, what is meant by adulterated milk? Adulterated milk refers to milk that has been tampered with or contaminated, often to increase its volume or mask its quality. This can involve adding substances like water, starch, or chemicals which can compromise the nutritional value and safety of the milk.
Question number 7. What kind of milk produces the best swirling of colors? Evaporated milk produces the best swirling of colors. This is because evaporated milk has a higher fat content than fresh milk. The fat molecules in evaporated milk act as a tiny mirror that reflects light, creating a more vibrant and swirling effect when mixed with colored liquids. The higher fat content also makes evaporated milk thicker and creamier, which helps to create a more pronounced swirling pattern.